Welcome again, Wildcats. All right, so if you would, today we're looking at Wednesday, September 21st, solving absolute value functions. I'm going to do that graphically, and that's going to be on page 13. So if you would, pause the video and update your table of contents. All right, now that your table of contents are updated, let's go on to page 13. All right. So we're solving absolute value functions. Before we do that, I want to review the definition of absolute value. Okay, the absolute value of x is equal to x, comma x is greater than or equal to 0, and negative x, comma x is less than or equal to 0. Because the absolute value of 2 is 2, the absolute value of negative 2 is 2, the absolute value of 3 is 3, the absolute value of negative 3 is 3, the absolute value of 4 is 4, the absolute value of negative 4 is 4. So there's a positive value and a negative value, okay? All right, so let's look at the solving steps. Now this is solving steps when we're solving graphically. So step 1, isolate the absolute value. That's the same one from before when we're solving algebraically. What's different is step 2, graph the left side. Step 3 will be graph the right side. And then step 4, we'll find the x values, either x values of the intersection. And you can use a graph or table to find those. Okay? All right, the types of absolute value function solutions are, there's 3 of them. There's no solution. That's when the absolute value equals a negative number, which we know the absolute value of any number is always positive, so this will never be true. But when it happens, graphically, you'll see that the left side and the right side will not intersect. Okay? The next one is if you have one solution, that's when absolute value of x is equal to 0. When that happens, you'll see that the left side and the right side intersect at 1 point. And if there's 2 solutions, that's the absolute value equals a positive number. The left side and the right side will intersect at 2 points. Okay, so if you would, pause the video, update your notes. All right, so let's move on to our examples. All right, now this video is going to be a little different in that I'm going to be absent today, and I was absent yesterday, and I believe I said in the last video is Temple is awesome. Okay, when we need resources, they get them. Okay, so Temple ISD knew that there was teachers doing the flipped classroom, so they hired the originators of flipped classroom, okay, the creators of it. So I'm in training today, learning more about the flipped classroom, okay? So while I'm gone, I'm going to go, like I would in class, I'm going to go through all the examples, okay? Now, I know that could frustrate some of you if you have questions, but if that happens to you, then you can always come with tutorials, and then I'll go over each example one by one with you. Or in class, if there's a lot of students, and we can talk about it, and I go over any of these examples, and we can discuss, get caught up. And because of that, I'm going to change the due date for this one to Friday, September 23rd. Okay, so the new due date is Friday, September 23rd. Let me rewrite that 23. Okay, because I'll be back on Thursday and I can answer questions on Tuesdays and Wednesdays lessons and things like that, okay? All right, so let's look at example number 1. Okay, first off, let's call this f1 of x and this f2 of x. Okay, so we're going to graph, and I'm only going to use the Inspire to graph example number 1. After that, I'm going to teach you how to use the parent function, which is this is, and use the transformations to graph, okay? All right. Give me a minute to adjust the lighting so you can see the calculator. All right. I believe I've got the glare taken care of a little bit, maybe. All right. So let's graph There's a little bit of glare on the top, but I think you should be able to see it. All right, so the graph, we're going to go to On, New Document, No, Add Graph, and we're going to graph the absolute value of x. So to graph that, we're going to press the button to the right of 9. The button to the right of 9, okay? And then it's this right here, and we're going to do x. And we're going to press Control T. All right, and the best way to get the points is, we know on the graph the farthest point is -10, so we're going to move all the way to -10. Okay, so we see that point is -10, 10. And then we do -9, 9. -8, 8. -7, 7. -6, 6. -5, 5. All right, I'm hoping that you start to see the trend. So I'm gonna scan through the points if you need to see them. But we're gonna move on to, we know 0, 0. Now that's your vertex, so we know the mirror image. Okay, so we know here our slope was going down 1 to the right 1, down 1 to going to the right 1. So here we're gonna go up 1 to the right 1, 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 up 1 to the right 1. Now, I recommend for you to write all the points, but to save time, a little bit time in the video, we're just going to use those points to get the quadratic parent function. All right. Now, in the calculator, I want you to see that it actually says f1 of x here. Okay, so we're going to press Control T, Tab, and I want you to go up. I'll get it out of the glare a little bit. So you see it says f1 of x right there. So now we're going to go down to f2 of x, and we're going to put 8. Press Control T. So Control T, click to the right to see the table, and I'm hoping you see that all the values are 8. Okay, so when x is 1, y is 8. When x is 2, y is 8. When x is 3, y is 8. So we're going to graph those. X is 1, 2, 3, 4, 5, 6, 7, 8. So when x is 1, y is 8. When x is 2, y is 8. When x is 3, y is 8. When x is 4, y is 8. When x is 5, y is 8. When x is 6, y is 8. When x is 7, y is 8. When x is 8, y is 8. So you can see that the right side is a horizontal line at 8. All right. So on your graph, you can see that this is the point of intersection and this is the point of intersection. So this point is -1, 2, 3, 4, 5, 6, 7, 8, 8. And this point is 1, 2, 3, 4, 5, 6, 7, 8, 8. Now remember, in the solution, in the steps, we said that we find the x value. So the solutions are x equals -8 and x equals 8. Right. Now that's the graphically. Now if you look at the table, if you go up to, see how none of the values are the same? If you keep going, when both the left and right column are the same, that's your solution. So at -8, we have 8, 8. So we'll write that down on our table. -8, 8, 8. So we can see that because these values are both the same, that our solution is -8. If you go the other direction, you see not the same, 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 not the same. Aha! At x equals 8, they're both the same. So you can see the solutions are x equals -8 and x equals 8. And you can see that from the table. All right, so I'm going to put the calculator aside, and we're going to do all the other examples without the calculator. I'm going to zoom up. There, no space. All right, so example 2. So the graph without the calculator, we know that absolute value of x right here, this is the parent function. Okay, so we know that this is our point, and we know the vertex is 0, 0. So we're going to start at 0, 0, and then we look at the transformation. That's +1 inside of the absolute value, so we know that's left 1. So we take the vertex 0 and move left 1, and there's a new vertex. And then we know that the number front here is the slope. And we know slope is rise over run. And I didn't say this, but I jumped to graphing because step 1 says isolate the absolute value. Well, in example 2, the absolute value is isolated already. Okay, so our slope is 1 over 1. So we go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. And then we know that the absolute value is symmetric about the vertex, so we know that this side is the opposite. So we went up 1 to the right 1, this would be up 1 to the left 1. So this one was up 1 to the right 1, opposite of that would be up 1 to the left. So up 1 to the left, up 1 to the left. Okay, so the right side, now remember this is f1 of x is this side, this is f2 of x. Now, I'm hoping that you see from the video that when the value is just a number, the y values are all that number. So in this case, when x is 1, y will be 3. When x is 2, y will be 3. When x is 3, y will be 3. When x is 3. So that side will be a horizontal line at 3. And you can graph example 2 like the method from example 1. All right, so our point of intersections are here and here. So those points are negative 1, 2, 3, 4, 3. So negative 4, 3. And this point is 1, 2, 3. So 2, 3. So we know from step 4 that we're looking for the x value. So our solutions are x equals negative 4 and x equals 2. All right. So in our table, we know that x is negative 4, x is 2. And so now let's look at both. So we know that at negative 4, this point is 2 for f1 of x, and at 2, this is 2. Well, I'm sorry, 3. F negative 4 is 3. And this point is 2, 3. Well, in f2 of x, all the values are 3. So since these are the same, we can see that these are the solutions. All right, what I recommend doing is pausing the video and trying example 3. Then after you've tried it, play the video, and you can see if you did example 3 correctly. All right, so example number 3. So again, we started the vertex 0, 0, because that's where the parent function starts. And then we can see that, oh, wait. I noticed that the absolute value isn't isolated, so we need to go to step 1. We need to isolate the absolute value. So to do that, we're going to add 1 to both sides. Okay, remember, step 1 is always isolate the absolute value. So negative 1 plus 1 is 0. So you get the absolute value of x equals 4. Now, step 1 says isolate the absolute value. This is isolated. Now we move on to step 2 and 3. So we graph the left side, which is f1 of x, and f2 of x is the right side. So we know that the left side is the parent function. So we know that 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, negative 1, 1, negative 2, 2, negative 3, 3, negative 4, 4. And we know that from example 2 that the right side is 4, so it's a horizontal line at 4. So 1, 2, 3, 4. All right, so this is our point of intersection. This is our point of intersection. So this point is negative 1, 2, 3, 4, 4. So negative 4, 4. And this point is 1, 2, 3, 4, 4. So again, in step 4, it says find the x values. The x values are negative 4 and 4. So x equals negative 4 and x equals 4 are the solutions. Okay, so we know that these points are negative 4, 4 and 4, 4. for f1 of x. And then we know for f2 of x, the values are all 4. So since these are both the same, we can see that these are the solutions. All right, so pause the video and then try example 4 and then replay. Then once you've done, then play it and you can look at example 4. So example 4, step 1, isolate the absolute value. So to do that, we're going to subtract 3 from both sides. 3 minus 3 is 0. So then you get the absolute value of x equals 0. Okay, so we know the left side is isolated and we know it's the parent function, so we know that this is 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 1, 1, 2, 2, 2, 3, 3, 4, 4. All right, so 0 is a horizontal line at 0. And you see that it intersects at 1 point. That point is 0, 0. So your solution is x equals 0. So in the table, we know that when x is 0, f1 of x is 0, and we know f2 of x is 0. And this is special in that this is one solution. All right, so pause the video and we'll look at example number 5. All right, so in example 5, to isolate the variable, we need to multiply both sides by 2/3. Okay, now we know that 2 times 3 is 6 and 3 times 3 is 6, so these become 1. And so then this becomes the absolute value of x minus 1 equals 3 times 2 is 6 divided by 3 is 2. Now, I think that's the part that would give you frustration before you can graph. So I'm going to leave it in this form and then let you finish the rest of it. Okay? Now, example 6, put a 1 in front. And to isolate the variable, we're going to divide both sides by -1. Okay? So -1 divided by -1 is 1. So we get the absolute value of x plus 1 equals -3. Okay? Now, to graph it, we know we start at the origin, but the plus 1 means we move it to the left 1 unit. And then we know the number in front is slope, which is 1 over 1. So we're going to go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. And then we do the mirror image, up 1 to the left 1, up 1 to the left 1. All right, now we know that the right side is -3. So then we here have, we go down -1, -2, -1, -2, -3. And it's a horizontal line. And we see here that they don't intersect, so there's no solution. All right, this concludes the examples. Remember, I'll be back on Thursday to answer any questions, okay? So with that, have a terrific Wildcat day.